You guys ready?
Yes. Yes.
Yeah, let's introduce yourself.
So first of all, good evening from Valle, Taiwan. My name is Jacob Shaw, and I'll be the second speaker today.
My name is Alondra Moctezuma, and I'll be first speaker today.
And we're so very excited to have this debate today.
Yeah.
Thank you for your time, of course, before we even begin.
Now I'll begin and start the first point of error. All right. May I please court your honor? I, Alondra Moctezuma, and my partner Jacob Shaw will represent the petitioner, the people in this case. Today, the question in front of this court is a very simple one. Is oil a finite resource? I will speak on the first point of error, how is oil created? This is a fundamental aspect of this entire case. We will prove how oil is actually created, how oil as actually is, and what is happening in oil markets today. To do so, we pose a question. Why does everyone seem to believe in the Hertz peak oil theory? Why does the public believe in this theory? Within our arguments, I present convincing evidence that the peak oil theory is based on false premises, that oil is a finite resource, and I will show how oil is actually created. Sir Fred Hoyle in 1982 commented, the suggestion that petroleum might have arisen from some transformation of squat fish or biological detritus is surely the slightest notion to have been entertained in numbers of people over an extended period of time. Sir Fred Hoyle, FRS 1982. Charles E. Melton and A. Gardini in 1983 explained the general concept of petroleum formation by a biogenic mechanism has been firmly entrenched for a long time, but there has been no accumulation of convincing experimental evidence in support of this belief. Currently, the publicly held theory is that oil and gas are both driven throughout the nature and fleet decomposition of organic detritus. Therefore, people would naturally believe that oil is a finite resource and that we will eventually run out of it. In this courtroom today, we will show you that oil and gas are continuously formed and replaced from a purely physical and chemical thermodynamic process that continuously regenerates from ultra-deep location, 19,000 meters. The inference here is that oil may perhaps not be a finite resource, and there is plenty of it. First, oil and gas origins, biogenic or abiotic. Do oil and gas originate from the biological decomposition of organic materials, or do they originate simply through the nature and physical chemical thermodynamic process involving just heat and pressure? It is notable of the whole Hertz theory of peak oil rests completely on the assumption that oil is a biogenic in origin. Therefore, oil is a finite resource. Simply everyone believes this because everyone believes that this is a proven fact. I have also read the biogenic theory directly contradicts and offends the second law of thermodynamics. Evidence for the Western biogenic theory of oil formation. First, in 1757, Russian scientist Milaho Lomonosov put forward a hypothesis and suggested that oil biological detritus. This was based upon a theory was first introduced by George Agricola in 1556. George based his work on Greek Aristotle's work in 1757, applying a little more observation and limited analytical tools available in this time. Russian scholar Milaho V. Lomonosov is generally considered to have farthered the theory that crude oil, after percolating for a great duration of time, might originate from a biological material. The notion that oil is a fossil fuel was first proposed by Russian scholar Milaho Lomonosov in 1757. Lomonosov's rudimentary hypothesis is based on a limited base of scientific knowledge that existed at the time, and on his own simple observation was that rock oil originated as a tiny bodies of animals buried in sediment, which under the influence of increased temperature and pressure acting during an unimaginable long period of time, transformed into rock and oil. 2.5 centuries later, Lomonosov's theory remains as it was in 1757. An unimproved and almost entirely speculative hypothesis returned once again to the Wall Street Journal. We find, although the world has been drilling for oil for generations, little is known about the nature and the resource of the underground activity that led to its creation. In spite of the great amount of scientific research, there remains many unresolved questions regarding its origin. Doesn't that seem a little bit odd, what we're talking here? After all, about a research that, by all accounts, plays a critical role in the vast area of human endeavors. Well, by one published account, petroleum is a raw ingredient in 17,000 manufactured products, including medicine, synthetic fabrics, fertilizer, paint, varnish, acrylics, plastic, and cosmetics. By many accounts, the very survival of the human race is entirely dependent on the ability of petroleum. And yet, we know almost nothing about this whole life sustenance of Earth's resource. And even though, by the shrill accounts, the well is about to run dry, no one seems to be overly concerned with the understanding of the nature and the origins of the so-called fossil fuels. We are rather content with continuing to embrace an approval of the 18th century theory that is subject to any sort of logical analysis seems ludicrous. As anyone who stayed awake during high school class knows, oil came from dinosaurs. As I remembered as a student, hearing my teacher go over and over the fact that oil was a fossil fuel, and we were running out of it. It seemed a reasonable idea at the time from a perspective of a 16-year-old. But as an adult, you really stop and give it some thought. Doesn't that seem, what's the word I'm looking for here? I remember, preposterous. How could dinosaurs have possibly created the vast oil fields? Did millions or even billions of them die at the very same time in the very same place? Were there dinosaur Jonestown on a great scale occurring of a location across the planet? And how did they all get buried so quickly? Because if they weren't buried away so quickly, wouldn't they just have decomposed and be consumed by scavengers? And how much oil can you really squeeze from a pile of parched dinosaur skeletons? How many dead dinosaurs does it take to make a barrel of oil? How many barrels of oil have we used so far? If dinosaurs caused the oil, or more correctly, their dead bodies had caused the oil, then shouldn't it be a simple formula to figure out how many dinosaurs it took to make the oil? Isn't that science in reverse? If oil were a fossil fuel, could you not figure out this one simple fact? Also, wouldn't that make all oil the same age? Wait, if oil were the same age, that would mean the dinosaurs made oil all die at the same time, correct? Maybe there was some type of catalytic event that caused a sudden extinction of dinosaurs and also buried them, like the impact of an asteroid or a comet. But even so, you wouldn't think that all dinosaurs would have been huddled together, waiting to become oil fields. And besides, scientists are now backing away from the mass extinction theory. Doesn't this seem without mass extinction, we could not have oil as a fossil fuel? Does it also mean that since oil we have today in one oil field was all made at one time, that oil had to come from some sort of sudden extinction? Even if dinosaurs lived for millions of years before, what did their dead bodies produce? Therefore, it would take a pretty big pile of dinosaurs to account for the estimate of 660 billion of oil in the Middle East. I don't know what the percentage of the dinosaur carcass to the oil conversion rate is, but it does seem like it would take a hell of a lot of dead dinosaurs. If we generally allow a single dinosaur could yield 5 barrels, an assumption, but let's play along. More than 130 dinosaurs would have been similarly entombed in just one small region of the world. But were there really hundreds of billions of dinosaurs roaming the earth? If so, then one wonders why there's all these talks of overpopulation and scarce resource when what we are currently dealing with is a few billions of human populations in the same earth. Couldn't the earth have had 130 billion dinosaurs in one place, like in the Middle East? Now, you would also have to multiply that with the United States, Mexico, Venezuela, Russia, Nigeria, and all the other oil-producing areas of the world. Quickly, you will see that we would have over 1 trillion dinosaurs on the earth, all dying at one time. We have found some of the fossil fuels, but have we found them in some of them in that type of scale? The answer is resounding no. And why the Middle East? Was that some kind of mecca for the dinosaurs? Was it the climate or the lack of water or vegetation that drew them there? Of course, the region would have been much different in prehistoric times. Maybe it was like the Great Valley in the Land Before Time movies, or maybe the dinosaurs had to cross the Middle East to get the Great Valley, but they've never made it because they just budged down in the desert and ultimately became cans of 10W40 motor oil. Another version of the fossil fuel story holds a microscopic animal carcass and other biological matter gathered on the world's seafloor, with the organic matter then being covered with sediment over the course of millions of years. You would think, however, that any biological matter would decompose long before being covered by sediment, but I'm guessing not. And I guess there's no bottom feeders in those days to clear the ocean floor of organic debris. Fair enough, but I still don't understand how those massive piles of biological detritus, some consist of hundreds of billions of tons of matter, could just suddenly appear so they can just sit there undisturbed for billions of years as they were covered over with sediment. I can understand how biological detritus could accumulate over time mixed in with sediment, but that wouldn't really create the condition of a generation of vast reservoirs of crude oil. So I'm guessing I might be missing something here. This theory is correct. Makes sense, correct? Have we found that most cases places have produced oil in the past, West Texas and Middle East, for example, were old seabeds, so maybe this theory is correct. It wasn't the dinosaurs entirely, it was all the plants and animals in the ocean that died. This makes perfect sense until you begin to place some questions like, did all the plants and animals in the ocean all die at once? How can you have oil created from the surface of the earth and have oil at the top the same age as the bottom? Simply, you can't, because according to their own theory, the oil had to be made all at once. For example, let's look at a cook preparing a large kettle of soup. He puts the soup in the kettle, heats the kettle slowly, and then adds different parts of the soup. As the soup is cooking, he continues to add ingredients. He adds ingredients until the exact same time the soup is served. Would all the ingredients be cooked? Would all the ingredients be done? The answer is, of course, not. I realize that this is a soup and it's not an oil, but the analogy is very much the same. You must question the fact that biologically speaking, for oil to be biotic, it would have a single source or cause and would have to cook from the bottom up, not the top down. This means clearly that if oil is a fossil fuel, fossils have to be found at the base of the deposits of oil. That means fossils will be found levels deeper than oil is currently being pumped at. Today, Russia has oil wells that are over 30,000 feet deep, and yet the deepest fossil has been found is 16,000 feet below the surface of the earth. In conclusion, let's compare the two theories of how oil was created and see which one makes more sense. In Lomonosov theory of 1757, you either have trillions of dinosaurs dying at the same time, plants and animals in the ocean dying. After they die, they all decay at the same time and create oil. Cross-apply these factors. First, for oil to be a fossil fuel, we would have to be overpopulated with dinosaurs. Second, they all have to die at the same time. Third, oil on top of oil field would have to be newer than oil at the bottom of the field. Fourth, fossils will have to be found at the bottoms of all areas and have been drilled. The interesting fact is that none of this happened. Bones of dinosaurs have not been found in numbers sufficient to justify point 1. No scientific evidence has been shown to cause point 2. The age of all oil fields doesn't differ, and fossils have been found only of 16 feet, even though they're producing wells that have been dug as twice as deep. Wherever the abiotic petroleum hypothesis first gained significant exposure as outside the Soviet Union during the 1977 gasoline crisis, when Cornell astrophysics Thomas Gould published an editorial in the Wall Street Journal, in which he claimed is the most deep hydrocarbon and generates abiotically in the mantle and migrates to the crust, where they act as an energy source of microbes producing a deep microbial ecosystem, the deep hot biosphere. That may rival the surface biosphere in the mass and volume. The organic remains of microbes in the deep hot biosphere represents the source of biological molecules in petroleum, such as biological overprint onto an abiotic organic mixture. The proposal contains an implicit concession that the biological molecules in petroleum cannot be generated by polymerization of methane. Echoing some of the previous arguments of Russian-Ukrainian school, Gould presents several lines of evidence for abiotic petroleum, including first, the presence of clearly abiotic hydrocarbons and other organic molecules in meteorites and other solar system bodies. Second, the possible synthetic pathway of mantle hydrocarbon production. Third, the association of hydrocarbon deposits with helium and other trace gases, presumably from mantle source. Fourth, the existence of the extents of deep microbial communities that import and overprint in biomarkers in abiotic petroleum. Fifth, the tendency of hydrocarbon reservoirs to occur at many depths in a single locally, implying an underlying deep source. Six, the distribution of hydrocarbon deposits related to underlying mantle structure. 7. The distribution of metals and other trace elements in petroleum, which correlate more strongly with chondrite compositions than presumed crustal source. And 8. The occurrence of hydrocarbons in a non-sedimentary formation, such as crystalline rock. Clearly, looking at both the abiotic and biotic theory of the creation of oil, we can see which one is scientific and which one is not based on facts. If there are no further questions, I would retire and allow my partner Jacob Shaw to stand and present the second point of error. We pray that you vote for the petitioner in this case. Thank you for your time.
May it please the court, I, Jacob Shaw, will now speak on the second point of error. If we know that oil is not biotic in composition and is definitely not finite, why are we still believing in a biotic formation of oil? Please cross-apply all my partner's points, and I would like to begin with a brief review of how I get into this discussion. The history of petroleum science had begun in 1757 when the Russian person naturalist M. Lomonosov suggested the hypothesis that oil might originate from biological detritus. During the end of the 19th century, famous Russian chemist Dmitry Mendeleev stated clearly that oil is a primordial, native material from great depth, mantle. The modern Russo-Ukrainian theory of deep, abiotic petroleum origins is not new or recent.
Excuse me.
Excuse me?
Yes.
A while ago, I asked Mr. Cunningham if we could go back and forth, so I assume that after your first speaker, it would be our turn.
It's your turn and then.
Oh,
it's
yes.
your turn.
That's perfectly fine. Sorry about that. Your first, we can go right ahead, and then I'll resume after him.
Would that be okay?
Yes, that's perfect.
Sorry to interrupt you.
So this is for the opposition on the debate. Oil is not an abiotic substance, and we do not have an infinite supply of it. Oil is a fossil fuel, and we have limited supply of it. Before beginning with the statement, the opposition would like to start from the definition. First, oil. Oil is the liquid form of liquid under normal condition of temperature and pressure. Second, abiotic. A substance that is abiotic is not produced nor synthesized from the biogenic process. Third, infinite supply. Something infinite supply means that it should be accessible to human beings and humans can unlimitedly use it. Understanding the origin of crude oil is no academic question. We need oil for our everyday life, and knowing where it comes from could tell us something about how long it will last. If oil comes from organic matter, as stated in the biogenic theory, it must be a limited resource, which will eventually run out. The following reason explain why oil is a kind of fossil fuel. First, instability of reactions in producing oil in the mantle. Second, prove that 99% of the oil is found only in sedimentary rock layers. Third, oil depletion and migration. Fourth, human impact on the carbon cycle. First, the instability of the reaction in producing oil in the mantle. Even if scientists can produce oil under the similar situation as the mantle, there are some problems in the reaction. Particularly, the stability of the reactions and the difficulty of using the reactions in 3 different phases. According to Mark A. Sampson, engineer in Imperial College London, and Robert M. Hansen, geologist of Carnegie Institution, Washington, the reaction that produces oil requires solid iron oxide, marble, water, the temperature over 1,500 degrees, and pressure over 3 GPa. However, under normal pressure, the melting point of iron oxide is about 1,500 degrees Celsius, and the boiling point of calcium carbonate is about 900 degrees Celsius. Now, the average pressure in the mantle is about 30,000 times more than normal. The iron oxide will indeed turn into liquid form, and the marble will evaporate. Only scientists can control the phases in the laboratory, but the natural environment cannot maintain those reaction states of matter. Also, even if a reaction can maintain the states, it will be difficult for a reaction in 3 states of matter to react. According to the collision theory, a chemical reaction requires sufficient activation energy and correct alignment. Even if a scientist can control a variable in the laboratory, there is still that chance that these matters in different states can react in the natural environment. The amount of hydrocarbon produced biologically is not enough for commercial use. That is why oil is kind of fossil fuel. Dr. Jonathan Clark, geoscientist of Commonwealth Scientific and Industrial Research Organization, CSIRO, mentioned that a low boiling point of crude oil may be different for oil in the mantle to hold its stage. The temperature of the mantle is more than 1,200 degrees Celsius. The crude oil will boil under such high temperature and pressure. The average temperature of the fractional distillation is about 400 to 500 degrees Celsius. If the temperature goes higher, there will be a progressive destruction. Most of the substances will melt or boil, and thus it will be difficult to collect. But our temperature deep in the mantle is over 1,200 degrees Celsius. The high temperature can make asphalt into liquid or even gas form. Gas is much more difficult to collect and is also dangerous because of stack effect or chimney effect. Stack effect is the movement of air into and out of a hermetically sealed space, which makes the air convection become stronger. The mantle is sealed and the gas released from the mantle is heated. When the air touches the oxygen in the atmosphere, there will be an explosion because of a high energy. According to stack effect, there will be an inrush of oxygen and will cause more explosion, and there will be no oil nor methane, but only carbon dioxide and water vapor. Therefore, the theory that oil is produced in the mantle biologically cannot be true. Second, the proof that 99% of the oil is found only in sedimentary rock layers. Oil is kind of organic compound, that is, there are hydrocarbon molecules inside it. 99% of oil is only found in sedimentary rock layers. Excuse me. 99% of the oil is only found in sedimentary rock layers where fossils are found. Only a slight amount of the crude oil is discovered in igneous rock layers and metamorphic rock layers. According to Dr. Jonathan Clark, there are gases found in magma volatiles or at mid-ocean ridges, but the process will not produce crude oil. Magma ascends through sedimentary succession, and organic matter will be thermally cracked, and some will be incorporated into a volatile phase. The upper mantle has also been contaminated with genuine organic matter through several billion years of subduction. Some Fischer-Tropsch synthesis can also occur, which transfer carbon dioxide and carbon monoxide into methane. That is the reason why scientists discover hydrocarbon gases in these certain areas. However, less than 1% of the crude oil have been found in the igneous rock layers because organisms are sent to the mantle, and the high temperature will make the oil progressively destructive. Also, some scientists claim that oil is produced in the mantle, but there is no evidence that crude oil comes from the mantle. In Alfred Wagner's seafloor spreading theory, matter released from the mantle contain high proportion of basalts. Nevertheless, only 1% of the crude oil have been found in igneous rock layer. That means only little or even no oil have been discovered in basalt rock layers such as mid-ocean ridges or Rift Valley. The evidence indicates that there is no abiotic oil produced in the mantle. Third, the oil depletion and migration. There are also some examples that oil fields are dried up. In 2010, Dubai, which prospered because of petroleum oil, encountered an economic crisis because of a decrease of petroleum oil in the oil field. In addition, the amount of petroleum oil found in North Sea is now on the decline. If oil were a kind of infinite resource, there would not be an oil decline. Some people claim that there is an increase on the amount of oil. However, it only occurs in few areas, and it is all because of oil migration. The mechanism of secondary hydrocarbon migration in entrapment, written by Tim T. Scowar, stated that the oil will leave its source rock and enter the reservoir rock because of buoyancy, and thus it will transport from one place to another. Oil and gas flow from water because of their low density, and oil migrates both vertically and horizontally through reservoir rocks with rock pores. That is, sedimentary rock, such as sand rocks and conglomerates. This explains the reason why oil can be found in igneous or metamorphic rock layers, as well as why there is an increase of oil amount in some areas. Again, the opposition wants to emphasize that oil is a kind of fossil fuel and it is indeed a limited resource. Fourth, human impact on carbon cycle. Human impact on our cycle during the combustion of fossil fuel. Fossil fuels were formed very long ago from plants or animals remains that were buried, compressed, and transformed into oil, coal, or natural gas. The carbon is said to be fixed in the atmosphere and is essentially locked out of the natural carbon cycle. In addition, in the carbon cycle, carbon dioxide is used in photosynthesis reaction and be stored as sugar in plants. However, the number of trees and plants is on the decline because of the deforestation caused by human beings. When we clear forests, we remove a dense growth of plants that have stored carbon in wood, stem, leaf, biomass. When depleting the forest, we eliminate plants that would otherwise take carbon out of the atmosphere as they grow. We tend to replace the original forest with crop or pasture, but they store less carbon. To make matters worse, the soil expels banned carbon into the atmosphere. Humans are currently emitting around 1 billion tons of carbon into the atmosphere per year through land use changes, but the speed of photosynthesis is not fast enough to reduce those carbon dioxide molecules. Thus, carbon atoms that cannot be transformed into organic compounds stay in the atmosphere. Besides, some carbon dioxide will dissolve in the ocean and turn into calcium carbonate, a stable mineral which is difficult to be transformed into oil or other organic substances. In the long run, there will be more and more carbon dioxide in the Earth's atmosphere, and the amount of oil will definitely decrease or even run out. That is why oil is a kind of limited resource. The conclusion of the first opposition is that oil is a kind of fossil fuel. It cannot be produced in the mantle because of the instability of the reactions, nor can oil stand a high temperature in the mantle. Oil is normally found in sedimentary rock layers, but less than 1% is discovered in other kinds of rock layers. This indicates that oil could not have been produced in the mantle, which is rich in igneous rock. Furthermore, some oil fields and oil wells had already dried up, such as oil found in Dubai and North Sea. These examples indicate that oil resource is limited. Last but not least, human impact on the environment makes the carbon cycle imbalanced. Due to deforestation, carbon dioxide molecules are trapped in the atmosphere and can no longer be captured by plants for photosynthesis. We would like to emphasize the controversy in the argument. We, the opposition, have provided significant evidence proving the origin of oil being biogenic. However, what the proposition has stated in her argument is simply negative and not accurate proof. We may not claim a certain belief simply by raising an alleged controversy in all this argument or theory. In this case, the proposition may not claim that since they were taught the knowledge that petroleum comes from dinosaurs when they were little, the fact that oil is a fossil fuel should be ignored without actually raising an accurate and significant proof that oil does come from a biogenic process, which is not. In this case, oil comes from one living organism such as algae, fern, not simply dinosaurs. Based on the above evidence, oil is a kind of fossil fuel, and we have a limited supply of it. Thanks for your attention.
Does that conclude your first speech?
Yes.
Okay, so if you're ready to begin.
Okay, sure.
All right. So beginning with the second speech for our argument, I'd like to first address some rebutting points against our opponent's claims, and then I'll be defending our own speech. So first, I'd like to start with an analogy. Here's my own personal water bottle. Let's pretend this is an oil well deep inside the earth. Under our opponent's theory for the biotic theory of oil, for no kind of pressure oil to exist at a certain point at the mantle, let's say at the bottom of my water bottle, for that to be true, which would happen is if I took my cap off of my water bottle and poured all the water out and put the top back on, then no oil would ever come there again, no water would ever be in my bottle ever again. But what happens is, actually happens in the earth is when it actually happens, we take oil out, somehow oil comes back in again. It certainly doesn't come from the top because the top is closed. And if all the fossils really was a fossil fuel and oil was only made because of the fossils there, and the fossils would either be gone at that point, or it wouldn't be able to produce enough. The only causation we can see is that oil would have to come from the bottom. It would have to rise up from the bottom of a water bottle. That would be the only way for it to become refilled. And that's exactly the logic flaw that's happening within our opponent's argument today. Specifically, they stated that at lower depths, there's higher temperature and more mass amounts of pressure than at the crust, for example, oil cannot be produced there because it would melt, which is certainly untrue. In fact, because of the higher pressure and the higher temperature, that's exact biological context for oil to mass produce in a primordial sense. Second, they said if oil were, because it's infinite, that we couldn't be able to refine it, which also is a erroneous claim. But the fact that we can continually refine oil for our processes today to fuel the earth means it is primordial because we've been able to continually refine it for decades. Third, they also did the plants and animals or biomass as a whole were the creation or origins for fossil fuels today within our earth, which is also certainly untrue. Because again, regardless of where you consider to be the biomass, we're talking about fossils or plants, they're only found in the earth at certain depths. But again, if we're going back to my water bottle analogy, oil itself is found far below fossils. So if fossils were at this point, oil is found farther below, which contradicts the whole fossil fuel theory in itself. Last, they also said that the efficiency would be wrong as well, which might make sense in the sense that oil was limited and actually was created by fossils, cannot be found in the mantle. But we also know this is false because if oil is primordial, you would see the deficiency is taken out because it's not a necessarily a scientific thing, but a natural occurring process. You can't apply with the scientific method in a sense because it's a naturally occurring thing. But as I get into my speech now, you'll see that oil is not limited, but it's actually unlimited in abundance. So first, the modern Russian-Ukrainian theory of deep abiotic petroleum origins is not new or recent. This theory was first enunciated by Professor Nikolai Kurdyev in 1951, almost half a century ago, and has gone on hints of development, refinement, and application since its introduction. There have been more than 4,000 articles published in Soviet scientific journals and many books linked with the modern theory. His writer is presently co-authoring a book upon the subject of the development and application of the modern theory of petroleum, which the bibliography requires more than 30 pages. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not the work of any one single man or a few men. The modern theory was developed by hundreds of scientists in now former USSR, including many of the finest geologists, geochemists, geophysicists, and thermodynamicists of that country. There have now been more than 2 generations of geologists, geophysicists, chemists, and other scientists in the USSR who worked upon and contributed to the development of the modern theory. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not untested or speculative. On the contrary, the modern theory was severely challenged by many traditionally minded geologists at the time of its introduction, and during the first decade thereafter, the modern theory was thoroughly examined, extensively reviewed, powerfully debated, and rigorously tested. Every year following 1951, there were important scientific conferences organized in the USSR to debate and evaluate the modern theory, its development, and its predictions. The all-union conferences on petroleum and petroleum geology in the years 1952 to 65 deal particularly with this subject. During the period when the modern theory is being subjected to extensive critical challenge and testing, a number of the men pointed out that there had never been any similar critical review or testing of the deduction hypothesis that petroleum might somehow evolve spontaneously from biological detritus. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not a vague qualitative hypothesis, but as a rigorous analytic theory within the mainstream of the modern physical sciences. In this respect, the modern theory differs fundamentally not only from the previous hypothesis of the biological origin of petroleum, but also from all traditional geological hypotheses. Since the 19th century, knowledgeable physicists, chemists, thermodynamicists, and chemical engineers have regarded with great reservations, if not outright disdain, the suggestion that highly reduced hydrocarbon molecules of high free enthalpy, the constituents of crude oil, but somehow have evolved spontaneously from highly oxidized biogenic molecules of low free enthalpy. Beginning in 1964, Soviet scientists carried out extensive theoretical statistical thermodynamic analysis, which established explicitly that the hypothesis of evolution of hydrocarbon molecules, except methane, from biogenic ones in the temperature and pressure regimes of the Earth's near surface crust was generally in violation of the second law of thermodynamics. They also termed the evolution of reduced hydrocarbon molecules requires pressures of magnitudes and counter depths equal to such an mantle of the Earth. During the second phase of its development, the modern theory of petroleum was entirely cast from a qualitative argument based upon a synthesis of many qualitative facts into a quantitative argument based upon analytical requirements of quantitative statistical mechanics and thermodynamic stability theory. It was a transformation of the modern theory from synthetic geology theory argued by persuasion to an analytical physical theory argued by compulsion. Petroleum geology entered the mainstream of modern science. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not controversial nor presently a matter of academic debate. The period debate about this intensive body of knowledge has been over for approximately 2 decades now. The modern theory is presently applied extensively throughout the former USSR as a guiding perspective for petroleum exploration development projects. There are presently more than 80 oil and gas fields in the Caspian district alone, which were explored and developed by applying the perspective of the modern theory, which produced from the crystalline basement rock. Similarly, such exploration in the West Siberia Crotonic-rich sedimentary basin developed 90 petroleum fields, of which 80 produced either partly or entirely from the crystalline basement. The exploration discoveries of 11 major and one giant fields in the northern flank of the Donetsk basin have already been noted. There are presently deep exploration projects underway in Azerbaijan, Tatarstan, and Siberia, directed to testing potential and oil and gas reservoirs in the crystalline basement. It appears that, unbeknown to Westerners, there have been, for quite some time now, two competing theories concerning the origins of petroleum. One theory claims that oil is an organic fossil fuel deposited in finite quantities near the planet's surface. The other theory claims that oil is continuously generated by natural processes in Earth's magma. One theory is backed by massive body of research representing 50 years of intense scientific inquiry. The other theory is an unproven relic of the 18th century. One theory anticipates deep oil reserves, refillable oil fields, migratory oil systems, deep sources of generation, and spontaneous venting of gas and oil. The other theory has a difficult time explaining any such documented phenomena. To which theory have we in the West, in our infinite wisdom, chosen to embrace? Why? The fundamentally absurd fossil fuel theory, of course. The same theory the peak oil doomsday warnings are based upon. I'm sorry to report here, by the way, that doing my homework, I never did come across any of that hard science documenting peak oil that Mr. Straw referred to. All the peak oil literature that I found, or cited elsewhere, took for granted that petroleum is a non-renewable fossil fuel. That theory is never questioned, or is any effort made to validate it. It's simply taken to be an established scientific fact, which is quite obviously is not. First, look at the abiotic hydrocarbons in space. Carbon is the fourth most abundant element in the cosmos, and remote observations indicate that the universe is replete with organic compounds produced without the influence of biology. The depth of the absorption spectra of dense molecular clouds reveal more than 150 small molecules. The greatest amounts of hydrocarbons in our solar system are associated with the gas giant planets and their satellites, where significant amounts are present in atmospheres and on icy surfaces. The prevalence of non-biological hydrocarbons in early stages of our solar system is evidenced by chemistry of carbonaceous meteorites, which represent fragments of ancient asteroids unchanged since shortly after the birth of our solar system. Carbonaceous meteorites contain percentage levels of organic matter that were generated in the absence of biology. The widespread presence of organic matter in the cosmos suggests that no exotic mechanism therefore need be invoked to propose abiogenetic hydrocarbons on Earth. In fact, the biogenic origin of some hydrocarbons on Earth is, thus far, a unique observation in an abiotic hydrocarbon-rich universe. In contrast to our cosmic environment, organic matter on Earth is associated primarily with biological processes. The distinction between biological and non-biological organic matter has a long-term fascination for scientists and philosophers. For instance, all ancient mythologies invoke divine intervention and use some abstract vital force for the production of organic compounds that constitute life. Following the 7th to 6th centuries BC, such viralist theories were often challenged by more materialistic concepts that assume only differences in levels of organization between living and non-living entities. A key moment for materialism came in 1828 when Friedrich Wöhler produced organic chemical urea from inorganic ammonium cyanide. It's a procedure now called the Wöhler synthesis. The generation of organic compound from inorganic material flexibility of non-biological processes to produce organic molecules and materials is an unavoidable conclusion, as the origin of life on Earth is by definition a process of abiotic organic synthesis. In general, organic compounds generated by abiotic reactions, or those that produce meteoritic organic matter, are characterized by complete structural diversity. Biological organic compounds produced by synthetic reactions directed by enzymes are notably specific in structure. Organic compounds of petroleum, by contrast, contain numerous structural abundances that cannot be produced by the random polymerization from methane. Second, experimental hydrocarbon synthesis. Hydrocarbon synthesis is achievable in laboratory conditions and in shallow geological environments, and several key reactions are notable. First, the Fischer-Tropsch synthesis involves the conversion of carbon monoxide or carbon dioxide to hydrocarbons. The products of the Fischer-Tropsch synthesis are low molecular weight hydrocarbons in a form of fluid spore distribution, where the longer the hydrocarbon concentration increases linearly with increasing carbon numbers. The Fischer-Tropsch process has been proposed to generate hydrocarbons in hydrothermal vent settings. Second, simple thermal metamorphism of carbonates such as calcite, dolomite, and siderite at 400 degrees Celsius in the presence of hydrogen gas can produce low molecular weight hydrocarbons. Third, thermal metamorphism of hydrogenates and graphite below 304 degrees Celsius may generate methane, as displayed in the following unbalanced equation. Fourth, methane is common at mid-ocean ridges and terpenization reactions are implicated. Hydrogen forms from hydration of olivine and can combine with hydrogen monoxide to form methane. In addition, For those reactions to proceed under conditions relevant to Earth's surface, the influence of pressure may be an important factor for synthesis. This environmental control is especially pertinent to the theories of deep gas and a number of experimental studies at elevated temperatures and pressures relevant to deep crust and mineral conditions points to the possibility of deep abiotic hydrocarbon synthesis. First, generation of petroleum hydrocarbons with the C-1022 was demonstrated using solid iron oxide, marble, and water at temperatures of 1500 degrees Celsius and pressures above 3 gigapascals, corresponding to a depth of more than 100 kilometers. Second, a heated diamond anvil cell had been employed to explore the calcite iron oxide water system at mantle pressures and temperatures. Based on Raymond's spectroscopic and X-ray diffraction evidence, methane and possibly other light hydrocarbon species were successfully synthesized. The experiments represent the first attempts to test the Western Ukrainian school hypothesis under conditions comparable to those found in the mantle. Subsequent experimentation has successfully repeated the observations. Third, pressures above 2 gigapascals and temperatures from 1000 to 1500 Kelvin appear to induce polymerization of methane to hydrocarbons, molecular hydrogen, and a graphite. The reaction is reversible under these conditions. Although elegant and efficient reactions exist that can produce substantial amounts of hydrocarbons from simple precursors in the absence of biology, care must be taken when extrapolating data to natural settings. Convincing evidence must be found that the production mechanism is contributing. Lessons can be learned from meteoritic organic matter studies where the attractive photosynthesis mechanism was supported even though ample evidence was available, but this reaction was not contributing quantitatively significant amounts of material to the organic inventory. Third, hydrocarbons and minerals. Evidence has been presented from organic protomolecule assembly in igneous rocks. According to Fruin's hypothesis, igneous most inevitably incorporate carbon and other impurities at high temperatures. As minerals crystallize, they also incorporate a small amount of carbon, which concentrates along linear crystal effects and form alkanes. However, these results have been challenged by mother workers. Fourth, abiotic hydrocarbons form hydrothermal vents. A number of authors have presented experimental, theoretical, and field evidence for the possible release of abiotic hydrocarbon species from hydrothermal vents. Hydrocarbons have been collected from numerous field sites. Observations of gas chemistry, abundance, and fluxes in various vent settings have provided an opportunity to assess quantitatively the relevance of proposed abiotic species to commercial oil and gas resources. Mean values of molar CH4-3 helium and mountain-derived fluids implied less than 200 ppm of abiotic gas are present in economically relevant reservoirs. These field observations of hydrocarbons from hydrothermal systems have been complemented by experimental studies that attempt to replicate natural conditions. A number of these experiments have demonstrated abiotic formation of methane and other organic compounds, particularly in studies that mimic serpentinization. Experiments underscore the important traditional elements and hydrothermal systems of organic molecules with heterotrophs type reactions. These results suggest an intriguing connection between mineral-mediated organic synthesis and molecular catalysts, many of which incorporate traditional mineral atoms at their radioactive sites. Biochemical reactions promoted by enzymes that incorporate traditional metals may thus represent reaction pathways that survive and evolve from the prebiotic geochemical world. Also, by the main argument put forward by Western biotic oil theorists that the biomarkers are always found to exist as organic detritus within all oil deposits, which is certainly true. But unfortunately, oil is inside the earth and surrounded by different types of geological soils, which all contain organic detritus. Also, and by the reverse argument, alkanes, kerogens, and many other petroleum-related chemicals have been found in meteorites, which can support no organic life. Caused by the fact that no fossils have been found below 16,000 feet, yet oil is being currently drilled upward to 40,000 feet. We're left with a controversy. Why are we not told the truth? 7 reasons why not told the truth about the sources of oil. First, in this paper, The Abiotic Oil Controversy, by Richard Heinberg, which sides with biogenic oil, with relatively little actual coded research evidence, has even admitted there's no way to conclusively prove that no petroleum is of abiotic origin. Perhaps one day there will be general agreement that at least some oil is indeed abiotic. Maybe there are indeed deep methane belts 20 miles below the Earth's surface. But the important question to keep in mind is, what are the practical consequences of this discussion now for the problem of global oil depletion? Classify the facts. Attempt to this. Classify some maybe. Although by doing this, the biotic oil theorists are really turning down their own theory. Classify the real problem for the biotic oil theories is not how oil is created, but it actually is running out. This is a logical fallacy, the creation of a false dilemma. How can you have a product that is unlimited? Second, American geologist King M. Hubbard predicted in 1956 that peak oil for the USA will peak in 1970. However, December 2014, the United States once again listed oil in production of oil, actually producing more oil than it did in 1970. That's by the fact the oil price from August 2014 to December 2014 fell by over 50%. If Hubbard's theory of peak oil were correct, neither of these two facts would have taken place. Clearly, peak oil and the price of oil are trying to manipulate the demands of oil by creating a false sense of running out of oil. With limited supply, demand and prices go up. Caused by the fact that supply is going up, prices going down, causing the best proof that peak oil as a theory is completely dead. Third, caused by the fact that laws of thermodynamics prohibit spontaneous evolution of liquid hydrocarbons in the regime of the temperature and pressure characteristic of the crust of the Earth. One should not expect there to exist legitimate scientific evidence that might suggest such could occur. Caused by there exists no such evidence. Nonetheless, and surprisingly, there continues to be often promulgated diverse claims purporting to constitute evidence that natural petroleum somehow evolves miraculously from biological matter. Fourth, oil is often called a fossil fuel, the idea being that it comes from former living organisms. This may have been possible back when oil wells were drilled into the fossil layers of Earth's crust, but today, great quantities of oil are found in deeper wells that are found below the level of any fossils. How could then oil come from fossils or decompose former living matter if it exists in rock formations far below layers of fossils, the evidence of former living organisms? It does not come from living matter at all. 2 days after I read this statement, I got to the following statement in a newspaper I deeply respect. Any geologist would tell you, well, most geologists would tell you, that oil was created by the magma of the earth. The oil wells in Pennsylvania are pumped out to dry at the turn of the century and capped are now filled with oil again. Say what? This response from Daniel E. Reynolds on July 29, 1996, on the subject of oil, a renewable and abiotic fuel. Caused by the only reason we're still being taught that oil is a fossil fuel is to control the price of oil and reading the story that we're running out of oil. Fifth, Academy of Sciences, Moscow. For almost a century, various predictions have been made that the human race is imminently going to run out of available petroleum. The passing of time has proven all those predictions have been utterly wrong. Caused by how all predictions have depended fundamentally upon an archaic hypothesis from the 18th century that petroleum somehow miraculously evolved from biological detritus and is accordingly limited in abundance. The hypothesis has been replaced during the past 40 years by the modern Russian theory of deep abiotic petroleum origins, which established petroleum as a primordial material erupted from great depth. Therefore, petroleum abundance are limited by little more than the quantities of its constituents as were incorporated into the earth at the time of its formation, and its reliability depends upon technological development and exploration competence. Sixth, one of the most success stories of practical application theory, the abyssal abiotic origin of petroleum and exploration is its exploration in the Donetsk Basin, or GDB for short, in the Ukraine. It's a cratonic rift basin running in a northwest southeast direction between about 30.6 degrees east to 40.5 degrees east. Its north and southern borders are traced from 50 degrees north to about 51.8 degrees north and 47.8 degrees north and 50 degrees north, respectively. And GDB's northern monadical flank, the sedimentary sequence is not containing salt-bearing beds, salt domes, nor stratovolcanoes, and no source rocks. Also, this flank is characterized by the dense network of numerous synthetic and antithetic faults. These faults create the mosaic fault-box structure of crystalline basement and the sedimentary cover, a large number of these fault traps, developed to declines for oil and natural gas, and alteration up lifts, or horse, and troughs or ravens. The structure of the DB's northern flank excludes any lateral petroleum migration across either the Donetsk fault belt or DB's Denver Caribbean. Consequently, the DB's northern flank earlier was qualified as not prospective for petroleum production due to the absence of any source rock of petroleum and the presence of any active, highly dynamic artesian aquifer. However, after a while, the prospectivity of this area was reinterpreted, re-examined, and compliance with the theory of the abyssal abiotic origin of petroleum started with the detailed analysis of the tectonic history and geological structure of the crystalline basement in DB's northern monoclinical flank. Subsequently, respective geophysical and geochemical programs were tested primarily for exploring deep-seated petroleum. Late in the 1980s, early 1990s, 61 wells drilled the DB's northern flank. 37 of them proved commercially productive. The exploration success rate is as high as 57%. Discovering commercial oil and gas rights in Kuchera, Chechnya, and Milikia, and other areas. A total of 12 oil and gas was discovered worth $4.38 billion in the price of 1991 and $26.3 in the price of 2008. To discover these new oil and gas accumulations, various scientists in Ukraine awarded the state prize of Ukraine in the fields of science and technology in 1992. Today, there are 50 commercial oil and gas fields in the DB's northern flank. Data obtained from drilling in many of these areas shows the DB's crystalline basement of northern flank consists of fibrites, trinikites, diorites, genesis, granites, granodiorites, granitogenesis, bigmatites, peridiotites, and schist. 32 of commercial oil and gas fields have either gas accumulation sandstones in the middle and lower Carboniferous age. 16 other fields contain reservoirs in the same sandstone, but separately from them, and amphibolites, granites, and granodiorites of crystalline basement as well. 2 fields contain oil pools in no crystalline basement only. 7th, a Russian book, Advanced Drilling Solutions, detailing deep and ultra-deep oil and drilling technology beyond Earth's crust sedimentary layers to depths of over 4,000 feet. And it occurs in quantity in geologic domains where oil is relatively rare absent, such as in fold and thrust belts, and some large basins such as the West Siberian and Taiwan basins, and depths below 15,000 feet. Natural gas has been found 21,000 feet in the granitic rocks of Sweden's Siljan meteorite impact crater, and the deepest ocean on the Earth in Oklahoma at 31,441 feet, and at over 40,000 feet on the Konoha Peninsula in Russia. It's peculiar to have been so little Western scientific peer review or acknowledgement or research verification concerning the ultra-deep Russian abiotic oil formation theory. Surely, this is suspicious and bears investigating, even if you don't believe the theory, because this world would certainly remove the geopolitical effects and problems of the current thing in the world that is running out. Concerning this theory, I've shown you why it is wrong. In the end, you would have to agree that the Russian abiotic theory of oil formation, backed by all this evidence, is far more likely to be the true explanation, and there appears to be little or no conclusive evidence to prove the Western biotic theory of oil. But that in and of itself leaves much unanswered, doesn't it? For what reasons then, in light of these fact conclusions and the peak oil theory being so heavily touted, a theory that is wholly dependent on the Western biotic theory of oil formation, which as I see it, is a completely unproven theory? Are Western geologists and scientists really that super unfair, or is there an underlying hidden agenda in media steerage here by the big oil major OPEC, perhaps discreetly encourage higher oil prices to promote a false scarcity of this resource by conveniently supporting the Western biotic theory of oil formation, now disproven defunct, so heavily promote previous peak oil theory? Follow the money. The only one to gain from this taunting this theory are our own companies themselves. They push oil to record heights and held the developed world hostage to their whims. Then, in summer 2014, a breaking stranglehold they once held on OPEC and exporting of oil. This is because of national greed and the fact that the U.S. is now producing vast more sums of oil. Prices have dropped by more than 50% from June 2014 to December 2014. I'll leave you with this question and a prayer. Would oil actually lose 50% of its value if we're running out of it? And why is it large oil companies that never really invested heavily into other forms of energy? Is it because they know that my partner and I do not have to because they will never run out of oil? Prepare to find for petitioners in this case, but for promotion of the truth. Thank you for your time. Don't have further questions. I will retire and allow you to begin with your second speech.
Thank you for the proposition second debate. And we'll now begin with the opposition second debate.
Assistant Principal, would that be okay?
Oh, you gotta repeat yourself again.
Okay. Yeah, Mary, we're going to introduce one of our assistant principals here. He wanted the camera right there.
Oh, okay. Hello, good morning. How y'all doing? My name is Carlos Martinez. I'm an assistant principal here at Del Valle High School. I just finally got a chance to come out here and say hello and witness this for my own self. I've heard great things. I've seen great things. I just wanted to come and say hello, good morning, and I'm very, very impressed.
Oh, yeah.
Oh, okay. Well, I know the time difference. I just wanted to introduce myself. Hello, and I'm very impressed, and I'm grateful for the opportunity that we're able to share this experience so far away. So once again, thank you and welcome online.
Thank you very much.
Mary, why don't you tell me a little bit about your program?
You mean what we have been accomplishing so far?
Yeah.
Well, we have been video conferencing with countries around the world, over 30 countries, and we've done a lot of projects with Michael, a very amazing teacher that you have over there, and his projects it's just growing so much. And we also did, in addition to the debates that you see here, we also do international education for life projects. We recruit donations for good causes like cancer research, and we also do environmental protection projects as well. And we're very pleased to be working with schools across the continent. It's just so amazing because students really get to use their language, and they also have a broader perspective of this world as they interact with peers around the world instead of just studying it in the textbooks. Definitely, and I couldn't agree with you more. I kind of wish I had this experience when I was their age. There's no more limits. You know, this type of interaction, you guys are blessed that there are no barriers anymore.
just simple camera and access to this type of technology, you can learn so much from anywhere. So once again, I just wanted to say thank you for the opportunity.
One more shout out to say, Enrique, unmute a second and say hello to Mr. Martinez and tell him a little bit about what's going on in Peru. Then we'll go back to Taiwan. Enrique?
Mike, can you hear me? Mike? I don't know if you can hear me. Move your head, please. Receive a warm greeting from Lima, Peru. I am gladly surprised for this fantastic connection. I am very grateful to Mr. Cunningham who invited me to share the explanation from Taiwan, Texas, and Austin. I will be integrated more frequently in this fantastic project. Really, I am surprised on how you can develop this fantastic subjects. As I said before, receive the warmest greeting from Peru.
Yeah, one more quick thing. Tell them a little bit about your restaurant project.
Oh, we are in this project trying to connect with interested high schools or college. We want to integrate the people who is involved in culinary or gastronomy items. We are a country which is blessed with more than 2,065 different kind of soups. We have the glory to prepare 365 different kind suppers during the year without repeating uh, any any meal during the year. We have 92 microclimates which are founded in 120 microclimates here in Peru. We have a lot of veggies and a great variety of fruits. But we want to make a culinary or gastronomy project by sharing the experiences of foreign chefs in which we want to integrate in this project. We want to make a community fusion.
Yeah, and not to interrupt you, but I know it's really late in Taiwan. One thing I wanted to say very quickly is that because of Enrique's help, they're going to start passing out the golden spoon for the school that offers the best recipes and stuff each month. So I really appreciate that. And we have our next video conference on next Tuesday, and I think we're going to have 22 different countries participating. So it'll be really interesting. So Enrique, thank you so much. You're more than welcome to listen again. And we'll go back to Taiwan, and I believe you had your second speech.
Okay, there's no problem, and thanks for the invitation.
Nice meeting you, sir. Thank you very much for the opportunity to participate today. I appreciate it.
Thanks, my friend from Texas, and my greeting to all the students at affiliated senior high Johnson University in Taiwan.
Thank you.
Thank you.
Bye.
Mr. Cunningham, okay.
Yeah, okay, go.
Thank you.
Thank you, sir.
I'd like to proceed on second debater on opposition side. First of all, in response to
the water-bottle theory promoted by the second debater of propositions, I'd like to use the same example to further provide proof that why it is impossible for oil to be driven or formed by biogenic format. First of all, you just mentioned that the bottom part of the bottle, which is where the oil is found, and at the upper part of the bottle where is the fossil is found. Actually, this is not controversial. Actually, this is a fact. It's because the oil found in the bottom part of the fossil is formed by the distant past of the fossil fuels. It is not strange to say that fossil fuels found on the upper part of the fossil do not indicate formations of oil from biological process. It is because the fossil fuels that form the oil from the bottom part of the fossil is actually more distant past than the upper one. And we did got scientific proof on this. The process is called radiometric dating. By assessing whether carbon-14, which is for the use of radiometric dating, to nitrogen-14, we can examine and assess the accurate time where the oil is produced. So this is certainly based on the accurate scientific proof. And the second, we provide the proof that abiogenic oil is impossible to be formed in a mantle due to the following reasons. First of all, hydrocarbons that could be formed down the mantle are simply methane or other forms of lightest gas. It's never going to be liquid, such as oils or fossil fuels that we were just discussing in this argument. And the second, even if methane and other lightest gas are formed, they are highly possible to be dissolved in magma when they're during the process of their migration. And then the third, which is the configuration of three states of matter down in a mantle. It is highly impossible for three states of matter to fuse together and produce the oil that we just mentioned. So now we'd like to begin. Oil is not an abiotic substance, and we do not have an infinite supply of it. In fact, oil is a fossil fuel, and it is now on its decline. The International Energy came to the conclusion of several assessments made by Cambridge Energy Research Associates and multiple other energy associations of the decline rates of petroleum in 2008, assessing that the average production rate of decline rate worldwide was 6.7% for post-date oil fields. What's more, with many petroleum basins reaching their peak and depleting, it further indicates that oil is a limited resource and that we're definitely run out one day. And as we've been suggesting that if the hypothesis were true that oil can actually be driven or formed in a mantle, and that it is highly possible that oil or hydrocarbons, these molecules, is highly possible to also be formed in the outer space in the solar system, because we have the same or nearly the same geological constructions or structures inside the planet itself. However, controversy arises as different phenomena are found. Theory suggests the existence of abiotic oil might claim that hydrocarbons are found in space, thus providing an evidence for the inference that there should be significant plentiful amounts of petroleum on Earth, which is located down in the mantle. However, according to Richard Piper, a senior fellow at Post-Carbon Institute, very recent evidence of methane in the outer spheres of Mars is being used as evidence of biological activity, probably in the distant past. Apart from this, there is indeed evidence for deep methane on Earth, which stems from the main oceanic ridges, presumably rising from the mantle, but that was methane. It is kind of gas. It's never going to be oil, the liquid form. And the amounts vented is relatively small. It is even less than the amounts emitted annually in counts of alien gases. Based on the studies and information shown above, it is clear that oil is a limited source, and it is found to run out one day. The statement, which deals with the fact that petroleum is biogenic and it is in limited supply, is established on the following points that come along with the evidence and proofs. First, biomarkers and ratios of carbon isotope found in the petroleum both indicate that oil is biogenic. Second, it's nearly impossible for fossil fuels to be formed in the mantle due to several environmental restraints. Third, Even if they are fossil fuels produced from the mantle, namely methane, they aren't sufficient to support the global demand for energy. First, biomarkers and ratios of carbon isotope clouds and petroleum both indicate that oil is biogenic. First of all, biomarkers are organic chemical remnants of once living organisms. Three subpoints are raised here to provide further evidence. For subpoint number one, oil typically contains biomarkers: porphyrins, isoprenoids, frestane, phetane, cholestane, terpenes, and chlorides, which are related by chemicals such as chlorophyll and hemoglobin. The presence of biomarkers in petroleum thus becomes a key indicator for an ultimately biological source of petroleum, which is a fossil fuel. Second, in addition, the maturity parameter concept relies on a relative instability of biological structures once buried and heated in subsurface. The biological isomers are progressively transformed into more geologically stable configuration. Two facts are listed here to support this subpoint. Such biomarker maturity parameters in petroleum are consistent with temperatures where thermal degradation heterogen would occur. Also, migrating fluids that extract biomarkers from multiple depths will result in mixed maturity signals that do not correspond to the predicted maturity of the predated source rock. Moreover, the biomarker inventory in petroleum is not exclusively derived from bacteria or archaea, but includes those from algae and land plants, which allows geochemists to trace oil samples to specific source rock. For the subpoint 3, the observed correspondence between biomarkers and source materials are not haphazard, but instead systematic and predictable on the basis of biotic theory. This significantly counters the scenario that oil picks up its chemical biomarkers through contaminations from bacteria living deep in the earth crust, which is suggested by pro-abiogenic theorists. For example, biomarkers in source rock can be linked with a depositional environment. That is, source rocks with biomarker characteristics of land plants are found only terrestrial and shallow marine sediments, while petroleum biomarkers associated with marine organisms are found only in marine sediments. As for ratios of carbon isotopes, the ratios provide an accurate proof of the petroleum origin. Geologists trace the source of hydrocarbon through analysis of its isotopic values. Natural carbon is nearly all isotope 12, accounting for 98.89%, by only 1.11% being isotope 13. Organic material, however, usually contains less carbon 13 or more carbon 12, because photosynthesis in plants preferentially selects carbon 12 over carbon 13. Oil and natural gas typically show a carbon 12 to carbon 13 ratio similar to that of biological materials on which they are assumed to have originated. The carbon 12 to carbon 13 ratio is generally observed property of petroleum and is predicted by the biotic theory, which provides evidence that it is not merely an occasional operation. Second, it is nearly impossible for fossil fuels to be fully in the mantle due to several environmental restraints. Data suggests that Earth's upper mantle is too oxidized to allow the existence of heavy hydrocarbons, namely oil. Only lighter ones, such as methane, stands a slight chance to be formed. Major forms of carbons in the upper mantle are diamonds and carbonates, and methane is merely a minor constituent and fluids inclusions from the upper mantle. Gases from the mantle are transported to Earth's surface and mainly dissolved in magma, and gases released are composed of carbon dioxide, water, and sulfur dioxide, and hydrogen sulfide. The concentrates of methane and nano-derived gases thus cannot be the source of commercial gas field. That's where economic difficulties arise from gas mixing, diffusions, or oxidations that appear owing to different reaction pressures. And this also provides proof to counter that since 1951, many experiments being promoted by the Russians or the Ukraine theorists. However, none of them that actually is successful in actually getting abundant oil as commercial gas, while those have been found in a sedimentary rock layer, which were fossil fuels, has actually this potential. However, it is depleting. Third, even after fossil fuels are formed in the mantle, the supply is insufficient enough to support a global demand for energy. After petroleum is formed in the mantle, it migrates upward, out of the mantle into the crust. This process results in the existence of petroleum vessels, which is a form of igneous rock. However, statistics reveal that when igneous rock or crystalline rock reservoirs are calculated on a global scale, they represent less than 1% of the world's petroleum deposits. In other words, the remaining 99% point to an overwhelming correlation of petroleum with sedimentary rocks, indicating a likely origin from sedimentary organic matter. What's more, the locations of petroleum within igneous rocks is only circumstantial evidence because fluids can migrate over a great distance. And this certainly explains why there are some increase in the supply, as you just mentioned, in certain post-trade fields in the United States. If we return back to over 50% of the oil, it is likely because of the migrations in the sedimentary rock layers. An experimental study in Monastrell, UK, is provided here as evidence showing that even the hydrocarbons are discovered in igneous rock. The origin of this is still highly controversial. Several analyses carried out in the early 2000s of Monastrell hydrocarbons revealed that the unresolved complex mixture contained about propanes and stearates, pointing to an ultimately biological source probably from organic-rich carbonaceous rocks and likely to be introduced by hydrothermal fluids associated with intrusion. John Pond, chair in geology and petroleum geology at the University of Aberdeen, believed this fire degradation mechanism to be a common occurrence that has significant proof to point out that all hydrocarbons in igneous rocks in the UK were formed from sedimentary sources. To draw the conclusion of the oppositions on this debate, we would like to re-emphasize several significant proofs and evidence that point to the fact that oil is fossil fuel and is in limited supply. First, oil is not depleting in many petroleum fields worldwide. For example, the most significant fields in Dubai and North Sea. Second, the biomarkers and carbon isotope ratios found in petroleum will indicate that oil is biogenic. Third, the migration of oil in sedimentary rock layers provide proof that fossil fuels found in deeper earth crust and increased supply in oil fields are the consequence of the biological process. However, that has been wrongly classified and justified by pro-abiotic theories as the alleged proof of biotic oil formation. Fourth, low heat resistance of petroleum makes it impossible for heavy hydrocarbons to be formed in mantle. Even if lighter hydrocarbons such as methane are formed, it is highly possible that they would dissolve in magma during the process of migration to the earth crust, which makes it commercially valueless. And fifth, with the imbalance of carbon cycle, since there is much slimmer chance for carbon dioxide, a resource of oil formation, to be obtained and used by living organisms, the chances for oil to be continuously formed also decrease dramatically, making oil to be limited in supply. Based on the statement mentioned above, we clearly believe and prove that oil is not a biotic substance and that we do not have an infinite supply of it. That's all for the second debaters of opposition. Thank you very much.
Are you unmuted? Okay. So at this time, since both sides concluded their arguments, I would like to open the debate up for questions. Would that be all right with you?
Yes.
Yes.
So may I take the first question?
Go ahead.
Yes.
So our first question for the opposition today is, as you know, the biomass they spoken of in their arguments, fossils and plants and things of that nature, are only found at about 16,000 feet in the depths of the earth. However, vast sums of oil are found in much greater depths. In Oklahoma, for example, at over 31,000 feet, in the Kola Peninsula in Russia at 40,000 feet. I'm even in China now, dealing outside on this coast of over than 40,000 feet. So how is this possible to find oil there at depths lower than where fossils are located, if oil is biotic in composition?
Well, there's a book called The Mechanics of Secondary Hydrocarbon Migration and Entrapment written by Mr. Tim T. Walker. Oil will actually migrate from one place to another, no matter vertically or horizontally. So if there is a reservoir of rocks with rock pores, which is sedimentary rocks by sand rocks or conglomerates, oil can actually go through those rock pores and go deeper or upper in the Earth's surface. So that's why oil can found even deeper than fossil fuels, or they can go up to the Earth's surface. That's the answer for the question.
And also, I would like to add a bit that 40,000 feet is only nearly 12 kilometers, which is rather shallow for such, as you just mentioned, abiotic substance to ever emerge from mantle, because mantle is believed to be deeper than 100 kilometers. So if that was the case, certainly this was not something derived from the abiotic substance that was in a mantle. Instead, it was something in sedimentary rock, which was the layers that has been produced by biogenic process.
Sorry, I didn't mean to cut you off there, but my counter to that is that, for example, that literally doesn't make any kind of critical sense when we're talking scientifically, because when looking at the inside of the earth and at those depths, when we drill for oil, it rises up significantly. Even if oil over the years were to always sink below the depths of fossils, it's very questionable, for one, how much oil would have been sunken because of fossils. That means there would have to be trillions of fossils within deep layers of the earth, which haven't been found. As my partner brought up, there have to be trillions of dinosaurs that would have died all at the same time in the same spots. And more so, if that were the case, where there's places where there haven't been fossils found, you can still find oil at depths lower than where you would find fossils. So I can't agree with the fact that you would see it as just being the fact that oil fluctuates in its placement within the earth, because even then fossils still wouldn't be able to explain that, because it's not like the fossils themselves fluctuate in place. They always stay at the same depth. But the mountain can always produce oil from the bottom. But to the sedimentary rock that you brought up, moving to my second question I had for you was, one example we used in our speech was the DDB's northern flank, the Dnipro Basin in Ukraine. For example, they were able to drill for oil at depths below where fossils are found, where no source rock is available for them to drill with, no sedimentary rock, in other words. And they had a 57% success rate, in the early 90s, which various scientists were awarded because they actually used an abiotic process and found abiotic oil. So how does that, how can you explain that under the biotic theory with sedimentary rock in relation to the DDBs, in the Ukraine?
Well, oil can migrate both vertically and horizontally, which is mentioned just now. And also take groundwater for example. When it rains, the raindrop will drop on the Earth's surface, but later on, some will evaporate and some will actually sink under the ground. So also, oil is a kind of liquid. If there is a pore, there's a space inside the surface, it can easily go downward, even under fossil fuels. For example, in sedimentary rocks. And also, not only sedimentary rock, if there is some cracks inside Earth's surface, such as the movement of continents, oil can also go in deeper from those cracks and go down into the Earth's surface. So that's why oil can be found under fossil fuels, and that is why they can migrate without sedimentary rocks.
And the migration certainly comes from the instability in the geological state, which means that, just as one of the partners of mine just mentioned, that one of the earth crust or other mid-ocean ridge, these are the places where geologically it's certainly unstable. And because of this, migration occurs. If that was the case, it is certainly justifies that the beings of oil being deep down where the fossils are not found, even the source rock. But we believe that. Well, certainly this is a fact, because we found in sedimentary rocks, because we believe that there is spaces for the oils to be transformed and migrate, both vertically and horizontally. And another example to add to that was that even you claim that there has been many experiments carried out in the USSR as well as Ukraine. However, none of them actually produce the commercially accessible oil or abiogenetic ones for the needs of the global energy demand. So if that was the case, was the oil not being commercially used simply because it was just a theory and not being able to prove and lack of several evidence?
My counter to that would be, first, just on talking about the USSR, former USSR. with that, there's over 300 wells in Russia right now being drilled to depths of lower than 40,000 feet, obviously thousands of miles lower than where fossils are found. And they're drilling oil abiotically for their country as well as the rest of the world. They just signed an agreement with China, in fact. But even then, looking back farther than that, when it was still the USSR in the 50s, for example, and actually supported this abiotic theory and held the all-union conferences each year from 52 onward to 65, and they continually refined and debated this theory at that time. Each year, they would continually drilling at depths lower and lower, and they became the number one producers of oil when they had none whatsoever, or reduced in oil composition because of previous wars. So I would have to disagree with the fact you say is weren't commercially successful in their theories when they obviously were, and were able to become the large producers of, in fact, oil in the world. But further on that point, with the sinking of oil, as you said, continually going lower and lower, if that were true because of the fluctuating position it has, doesn't that contradict your earlier proposition that at the mantle, for example, I'm assuming that if oil keeps sinking, it can sink lower into the mantle, it would melt any oil that's found there. So if you're saying that it's continually sinking, wouldn't oil be just continually reducing and we would never find any because it would have already melted already if it were continually sinking into the mantle? Because you said that as there's that much heat there and that much pressure on oil that it would disintegrate. It can no longer be sustained because of those kind of conditions. And you said if it can't be found in those conditions, but if it's sinking, then it is found in those conditions. That's one problem I have with your logic there. But second, even then, wouldn't it melt and we wouldn't have any of it right now? Because all of it would have sunken over the centuries it's been inside the earth now.
Well, actually, oil was not just sinking. Another example is the capillary phenomenon. Is that if there is small spaces inside the surface, liquid like water and oil can actually climb up from the surface. That is why oil can go upward inside rock pores. So because of capillary phenomena, oil will not just simply sink down into Earth's surface or mantle.
And as you just mentioned, there's not a proof that why the oils will not sink down to the mantle. It is certainly because the mantle is too deep down in the earth. Just as we mentioned, it is nearly 100 kilometers. Well, the oils that you displayed was only found in 12 kilometers. So the sinking for this tiny distance is not difficult to imagine about.
Because the density of oil is smaller than water, so if there's groundwater under oil can actually float on the groundwater and go even upward in the earth.
So I just have one more question for you, and then you can turn over questions to ask our side today. My last question is, in going with your theory now that oil is continually going up or down, it's always fluctuating. It's not very sure now because first you said down and then you switched to up. But regardless, if that were true, and oil was always moving in one direction, we're continually drilling for it, and you're saying oil is limited, then eventually by now we certainly would have ran out of it, or we would have been capped somewhere in the world, as they told, for example, the United States, they said in the early 1970s we'd be capped by 2000, as well as many other countries around the world. However, we're continually always producing more vast sums of oil than we're able to find, or more than we thought that we had originally. More so with the price drop of oil by over 50% last summer, August through December. If oil were limited in abundance, how is it possible that oil companies would have been able to reduce the price of it if it's such a finite resource? Doesn't that completely contradict it being limited?
Well, first of all, I would like to counter the latter part of your argument. You mentioned that since last summer, 2014, we've seen the oil prices being going down, and certainly this is the result that everyone was pleasing to see. However, consider this situations. Even if you find the abundance resources of oil, which in this case, you claim that it was abiotic oil. The only situations that happens is that we keep burning these oils, and what happens was that we release carbon dioxide and other greenhouse gases into the atmosphere. So the result and the consequences of this will also push a lot into the global warming, which is what we concern a lot in the 21st century. And this is certainly not what we want to see. So this, as we can claim before, this is not the problem of whether we want to do it or not. It's because we want to avoid this other side effects that possibly would happen after the keep burning the oil. So even with an abundance supplies of oil in the mantle, which is certainly not proof in this case, even that did happen, it will not solve the problem, because the problem that is most serious, and we are trying to solve right now, is the climate change problem. It's never going to be the energy price problems that we've mentioned in this case. And also, let's focus more on the biomarkers and the carbon isotope instead of just oil being up and down in the mantle, because this is certainly has not been proved and is controversial. What is found was that biomarkers and petroleums and carbon isotope ratios, this has been proved and provided significant evidence for the biological process in these petroleum. And as for the biomarkers, I would say lots of bacteria, and not only bacteria, many other elements that I've just mentioned in the previous arguments, and also the ratios of carbon isotope, where the carbon 12 we have seen its increase because of the photosynthesis process. This all indicate that oil will be biogenic, and I would say that was a counter for better arguments.
Yes, and also from the radiometric dating, we can know that when the oil is formed and the relationship between oil and fossils, scientists may have done the analysis between the biomarkers and the oil, so that they will pose its theory to the growth. So that it proves that oil is a kind of fossil fuel.
Questions? At this time, if you had any questions for me or for our side, I'd be more than happy to answer them for you.
Yes, we'll start right now. So the first question for you is that the upper mantle is still oxidized, but it will cause the oxidations, the hydrocarbons after they are formed. And as the other cases that we just mentioned, the three phases or the three state of matters, which is the elements needed to be formed as your alleged abiotic oil, cannot fuse together down the mantle since they are in three different states of matter. And third, as what we've been proved, that the methane or the gas produced during this process will certainly dissolve in the magma. So based on these, how did you prove that there is such things like the abiotic oil that did produce from this preferentially unstable environments down in the mantle?
I'm sorry, I didn't quite hear it was a long question. I didn't quite hear your first part of it. Could you please repeat your question?
Well, I've summarized into 3 points for the first part. First of all, there are 3 points that indicate that it is nearly impossible for abiotic oil to be formed, as there has been environmental restraints, as we just mentioned, and after the oil is formed, it might dissolve into magma. So how would you prove that? There was abiotic oil that was formed in such harsh environments in the mantle. Since you haven't drilled that deep, and this certainly cannot be an accurate proof, if you just certainly say it by it is not going to be in biogenic form, so it must be an abiogenic oil.
Right. Okay. So I think you've clarified for me, and thank you. So my response to those 3 critical aspects. So the first aspect is that, following under your logic, that might be true in a scenario if oil was composed of or from biological material or biogenic material, being plants and other organisms such as particularly fossils. However, what we know is, and what we advocate today, is that oil is in fact quite the opposite. It is, of course, abiotic, and because it's made up by the mantle, it composed by the mantle with those temperatures, and because of those pressures, well, it may be an unstable environment. It is scientifically proven that oil is continuously found there, not just a bit, but vast sums. In fact, it makes more logical sense for it to rise. And that's exactly how drilling works. When you drill deep enough, you can actually make the oil rise because it's already at those depths, because it's trying to come up, because of the building pressure that's at the mantle, and because of the building heat. It's exactly what wants to shoot directly up. If we're falling under the abiotic false stream theory, of course, sinking would make sense, but an oil wouldn't want to rise, as well as the fact that you wouldn't be able to necessarily continually keep drilling for it because it would have already ran out. But in fact, it actually does. Second, as far as the gases, for example, well, looking at methane, if you consider methane in the gas giant planets in our solar system, we see that methane can be found there. Vast sums of quantities of it can be comprised, but no life whatsoever, no, whether you're talking about fossils or plants, is found there, nor can it any biological life be sustained there, as we know. So because it can also be found there, we know that actually those gases can be comprised in abiotic conditions, and they're abiotic gases. But it further proves that the origin of our life in general was by an abiotic process and not a biotic process. If looking at that with oil again, we see that it actually can be proven as an abiotic source, and actually is abiotic, because those same gases we know can be comprised in abiotic conditions, such as in gas giant planets, can certainly be done on the Earth, which we believe in, it has been done continually. And then the last third on that same significant factor, it just makes it more plausible for oil to be abiotic in general, because there's no other way for it to have so much of it. Yes, have so much of it. Sorry.
Well, since you mentioned that there's methane on the Earth's crust in the mantle, yes, Fischer Frobisher synthesis do produce methane. Only methane is a kind of gas, not oil. Simply in the definition, oil is a kind of liquid. But methane, however, is gas. And methane will dissolve in magma, or because of the oxidized environment inside mantle, methane will be oxidized. And the only way to oxidize methane is that it will burn. This is the only way in chemistry. So after methane is burned, it will turn into carbon dioxide and water. So how can oil be produced under such environment that there's even no methane synthesis already burned?
Again, I would defer to the gas giant planets and their ability to produce methane without any sort of biological life whatsoever, as well as the fact that, again, looking at the conditions of the Earth at the crust, at the crust versus the mantle, because of the higher pressure, because of the lower depth, as well as the higher heat, it's a much more conducive environment or context for oil to be formed, as opposed to that high within the Earth. Especially since, again, we're continually producing it at depths lower than you would find any type of biotic material, such as fossils and plants and organisms. My direct counter to that is because we're finding it below biotic, any type of biotic material, which just sinking can't explain, because you can't explain why it would sink that much at this given time, at this given place, et cetera, et cetera. There's so many variables that doesn't explain in biotic theory, but it has to come from an abiotic source, abiotic foundation, and rises up. Maybe even given the appearance that it might come from fossils, because it's so much lower than fossils, you find much lower fossils, it rises up, and then maybe it comes to the level where fossils are. But that'll be the only scenario in which you'll be able to explain it, or even maybe confuse it as becoming biotic in composition. Any further questions?
I got a further question for that. Since the experimental fluid inclusion showed that methane accounts for a rather tiny percentage compared to other forms of gases that were found in the mantle or in the upper mantle, or even in Earth crust, compared to carbon dioxide or water, it is rather tiny. It accounts for a rather tiny percentage. Also, with the drilling technology, would have progressed that advanced that dramatically. At least it would not advance that dramatically in the near future, where drilling technology would be drilled down the mantle for 100 kilometers. Since the temperature in the week is 22 times, going to be over 1,500 degrees Celsius. So if that's the case, how would you be able to keep holding that you have the evidence that there was an abiotic oil that was being found, given there was countless experiments, and as I just been said before, as I have said before, that there aren't any successful one that did has commercial potentials for creating such oil, as you just mentioned?
So first, I would defer to, again, the gas giant planets and their ability to produce methane without any biological life. And second, I would say that with the advancement of technology, being able to actually get a depth set to find oil, it's not really a matter of advancing technology. Well, it'll get better, obviously, but you don't need to look at it in the contemporary sense. Look back to the 50s again with Russia and how they completely went from no oil to the largest oil producer throughout the Cold War. We see that because they were able to drill the depths, just with that technology at that time, 20th century technology, it's proven that you don't need any type of quote unquote advanced technology to find oil at those depths, that you always have to keep drilling. And yes, it's not, I understand it's not as cut and dry as that on paper. However, there are reasons for why the Russian-Ukrainian theory is necessarily that intertwined with the West. The documentations of various scientists who perform experiments and actually prove this theory. They're not necessarily translated for the West. At this time when they were conducting these experiments and finding oil at deeper depths, when the U.S. is trying to be anything but Russian, be completely anti-Russian and anti-communist, and just profuse its American identity and find its own American identity, it wasn't trying to adhere to any Russian beliefs or any Russian types of science. And last stir, the big oil companies, regardless of, especially in the U.S., to keep making money, they can keep us ignorant. They can keep us believing that you can't find oil at those depths. You can't believe that it's impossible to find oil at those depths. They can keep us believing in a reality, a false reality, if you will, that oil is going to only melt at those temperatures, that oil is going to be limited in abundance. They can control the price. But if we see that this failed on them, because one, we see that the oil prices dropped significantly last summer through December. And second, they haven't made any strides to push for any other form of energy. That might be another critical point, is that if biotic oil theory were true, then certainly if we knew this, even before the mid-1800s or so, then certainly big oil companies, as well as scientists, have been looking for significant or viable methods of attaining energy in other areas. But oil companies haven't done that. The only thing they've done since is just profited from promoting a false dilemma to the world.
We got one final question. First of all, I would like to say that for those oil companies who claim that the oil is depleting and now it's post-peak, it's not because they want to grab the money or take any advantage from it. It's because they are stating the facts. And if that's the facts, of course, they need to tell the public and tell that we need to pay more effort into the alternative energy sources, and that will certainly benefit the whole environment as a whole. Yeah, and the question is that it's not about the economy, but it's that about hydrocarbons in outer space. Although they are actually methane found in outer space in our planets, but again, methane is a kind of gas. There is no evidence that crude oil liquid have been found in other planets or in our solar system. So this situation, since crude oil is only found in Earth, which is the only planet with organisms, how do scientists prove that oil in outer, how do scientists prove that oil is formed in an abiological way from outer space?
Okay. Do you have any further questions?
And the final one.
I'm sorry?
That is a final question for.
Could you repeat the question?
Yeah, I'm sorry. Could you repeat the question? I didn't exactly hear. I didn't exactly hear the question.
Oh, sorry. Okay. Actually, there are methane be found in space, but there is no evidence that oil have been found in other planets. So this situation, since crude oil is found only on Earth, which is the only planet with organisms. So the question is, how do scientists prove that oil is formed in an abiological way?
Well, I mean, that's this is a red. That's logical fallacy of a red herring. It's because I'm sorry, that would be logical fallacy of cause and effect, because one thing's happening that it's certainly causing another, which there's necessarily a link. To put it in simplest terms, we see that while there are biological life on Earth and nowhere else in the universe, so far as we know with our limited scientific means to explore the vast sums of the universe, we see that again, oil was found at layers miles and miles below where you would find any type of organic or living matter. Because of that, we see that while there is organic matter within the depths of the crust, we're not denying that, or in Earth in general, we see that it is still possible for oil to be formed, and actually is how it's formed in abiotic conditions, at abiotic depths, as opposed to biological depths. Further, second, we see that even though there's only place in the universe we know so far with biological means and biological context, and therefore you would expect oil to only be found here because of the biological means, actually isn't the link if you look at the science of it. For example, again, and I can't push this enough or say this enough, looking at methane, for example, and the whole oil argument, it's found on planets where there isn't any life whatsoever. So again, we can conclude that if it actually applied that to Earth, then it could be formed without the presence of biological life or form of living organism matter, because if we didn't have it on here, then it could still be formed, able to form a gas giant planet. Certainly could be still formed here, which it has and which it is, without the influence of biological matter. So because of that, we see that oil in the earth is primordial. Even if humans weren't here, it would still be being formed. With that, thank you for your final question. I think we can conclude this debate here. And I want to thank you for your time. And it was a wonderful time, a great pleasure. My partner I really enjoyed being able to debate with you today.
Bye.
Thank you very much. This was one of the best, as Michael had mentioned. Good job at the Valley. And it was Jacob, and I didn't catch your name at the beginning.
Alondra.
Okay, yeah, Alondra. And so we have Tony and Anson, and very good job. I'm guessing that you're both seniors as well?
Yeah.
Yes, ma'am.
Oh, yeah, we both are seniors here, so you all move forward. The four of you will be graduating soon. So sorry to see you though.
Bye.
Until next time.
See you next week.
Yeah.
Good night.